Welcome to the Building Efficiency Resources podcast, the BERcast. We are here today to commemorate the 5-year anniversary of the release of the ACCA RESNET ICC 310 HVAC grading standard, which was released just about 5 years today. Yeah, I can't say that people are really using it for 5 years, but I think we've had a good few years now as practitioners in the building performance industry to get our hands on it, to get our hands on some new, exciting tools, maybe things you saw in a catalog from the Energy Conservatory and said, wow, what's that? I've always wanted that. Now people have been putting those tools into their hands, and really, I'd say, as an industry, upping our game in terms of our knowledge of HVAC design and installation best practices. But how has it really been going? Has it really been effective in the actual real world implementation? That's what we're here to talk about. And we have some esteemed colleagues from around the industry in order to sit in and talk shop with us about their real life implementation of that standard. We have Rick Cobbs with the Energy Network Worldwide based in Minneapolis, Minnesota. We have Stephen Gleaves and Chris Urbanus with Burgess Construction Consultants. They're headquartered in Texas, but have offices around the country serving home builders. And then we have BER's own Tindall, who has been really the industry's leading on-site trainer for the ACCA 310 standard, putting the tools in the hands of the pros to get them comfortable with going out there and implementing the standard. We're here to hear from all these gentlemen about exactly how things have been going. Thanks, gentlemen, for joining us. Appreciate you being here on the BERcast.
Glad to be here.
Thanks
Glad to be here.
Right on. Okay. We're going to go ahead and just kick this off by saying, can you believe it? 5 years that this standard has been out. It doesn't feel like it's been out that long. I guess I'd have to go back to my history notes about when were the webinars available? Because after the standard came out, RESNET created some mandatory webinars that people had to take. And that sort of got you in the game for being able to even consider becoming an HVAC grading implementation professional. Probably took a while for the software vendors to get up and running with it. I'm going to go ahead and say I think it was probably somewhere around early 2021 that this thing really started to gain a momentum from just being hypothetical or theoretical to being real. But hey, those RESNET webinars, PowerPoint talkovers of the standard, they were okay. They got us going in the right direction, but I think there's a lot more that we've since learned, and that's what we're here to talk about. So, Rick, I'm going to kick it off with you. Maybe just tell me a little bit about, first of all, tell us a little bit about the Energy Network Worldwide and the work y'all do, and then what's been your kind of early experience here with the 310 standard.
Yep. Yeah, my name is Rick with the Energy Network Worldwide. We're a HERS rating company out of Minnesota. Nowadays, we're about covering the whole state of Minnesota, primarily the Twin Cities metro area. I saw 310 years ago and just blew it off. Never thought it would come to fruition. Frankly, I'm in a cold climate. Why do I need to get into this? And as we moved into Energy Star for the tax credit, we actually had a national builder who mandated that they were going to go to 310 as a part of doing Energy Star because their concern was the HVAC contractor was not doing the commissioning checklist, which is optional to turn in for the rater to collect. And their concern was Energy Star was going to go back and ask for them, and the HVAC contractors wouldn't be able to come up with them, and they might get their tax credits rescinded. So that was their concern. Yeah, I mean, we did roughly 170 houses last year with ACCA 310. Had 5 of our 6 RFIs up to speed in the field testing, and that really took a while developing procedures and stuff for how that works. So they're not taking 4 hours a house to get in and out and stuff.
Yeah, and I'm particularly interested in hearing from you. It's great because we have got some cold climate representation, and then we got hot climate representation. Chris and Stephen, I'm not sure who wants to go first here from your team, but tell us a little bit about Burgess and then y'all's experience. Have you been doing it nationwide in just certain markets, and what's the early takeaway?
I'll take a run at the first part, and then Steve probably has much more information. So my name is Chris. I'm from Burgess Construction Consultants. We're a nearly 40-year-old company. We started off doing quality assurance. That's still kind of our bread and butter, doing quality inspections for builders all across the Smile States. We got into the energy rating business about 15 years ago, and we've grown that business across all those same states. And similar experience, we built builders pushing towards getting the HERS credit. We're primarily performing it in those hot climates. Arizona is a big market for us doing it. A lot of credit there. Builders are doing heat pumps, and it's a cooling climate. 7 or 8 points is not unusual for a builder there. So a big boon for the tax credit and the Energy Star compliance side of things. But challenges all across the board. Everything you already mentioned, Chris. HVAC design checklist, can we get them? When we get them, are they any good? And then also getting people up to speed. So I'll let Steve jump in with that, where he's had a lot of impact on the field performance and getting our RFIs and raters up to speed as well.
Thanks, Chris. Yeah, it's been a challenge. I think actually not as much as I was worried in the beginning of this process. AC contractors, since we use similar processes to what they're using, we're typically talking apples to apples, makes the whole thing work a whole lot better, quite frankly. And I think in the beginning, yeah, paperwork's a struggle. It's always a struggle anywhere in our industry, getting plans back and forth, plot plans, et cetera. So paperwork has been more of an issue, I think, than the field. I think the field's gone very well, quite frankly. We're able to get in and out very quickly. We're able to get good data. The data, the more we track, the more we get, the more we can solve problems and find solutions for our clients. It's effectively stopped numerous problems that it was designed to stop. It actually catches issues in design and construction and products, and I believe it delivers what it's supposed to deliver. So overall, I'm happy with it. I like it. I like the way it works, and I hope that people will continue to do it, whether they get points for it or not.
Okay, awesome. And then finally, we got Dylan Tindall here with BER. Dylan, you've probably done a little bit less practitioner yourself, but you've been training a lot of people on it. What are you hearing around the country when it comes to a lot of people who I'm sure you're working with? They've already maybe dabbled in trying to implement it. And through our HERS providership, we've got raters all around the country who call in and email with technical support questions. And no doubt you've been answering a lot of those. What are you hearing about the standard 5 years in?
I think what I'm going to say applies to a lot of stuff in this industry. And just because this is a new standard, I think people treat it differently in a way. But it's one of those things where if you do it over and over, eventually you're going to get a lot better at it and you're going to start doing it much quicker. And for instance, like Energy Star, if you pick up a builder and their Energy Star and they're only doing 5 homes a year, you're going to spend so much more time on those 5 homes than you're going to spend on a builder per home that does thousands of homes in the same year. If you got a new HVAC contractor, same thing. If you get used to it, you will get used to it eventually. If you're a rater and all you do is blower door tests, at a home comes up, it has a duct leakage test, you're going to take probably 3 or 4 times as long on that home than you probably should because you haven't done a duct leakage test in forever. It's the same thing with the standard, except that the standard has multiple steps and each step has multiple pathways and every house is going to be a little bit different. But if you're doing production builders, once you figure out a couple of homes, you're going to be able to bang out the rest of them for the rest of the year. And the next year, it'll be easy. But if you're doing custom homes, it's really hard. And every HVAC contractor, again, same thing. You're going to have to work with them. Once they get it, you're good to go. But every time you deal with a new one, it's going to be a struggle every time. And again, it comes back to people see this new standard and they think, oh, it's all complicated, this and that. Yeah, our jobs are complicated. Everything in this industry is complicated. We've just been doing this stuff for so many years that we've made the complicated stuff not so complicated anymore. And this is just another standard to add to our toolkit. So.
Yeah, Dylan, I appreciate you framing in that perspective because it really is. It's the next frontier of what it means to be a home energy rater. And no doubt, given another 5 years, we'll probably have something even new, brand new that we're doing in order to assess building performance. And that's one of the things that keeps me going and excited about this industry is that we keep finding ways to improve the products that builders are delivering to consumers through more detailed evaluations. If you think about it this way, blower door tests were not mainstream 20 years ago. They weren't. They were an option. And in parts of this country, they're still not mainstream, but it's something that seems so fundamental to our industry, honestly hasn't really been utilized at large throughout the whole country for very long. Duct testing, especially like total duct leakage, especially, because Rick's up in a cold climate. I'm in Detroit. Rick's up there in Minneapolis. And what do we say about ducks up here in the cold climate? Hey, if they're inside the house, doesn't matter if they leak. Just let them blow. You can just disconnect it altogether. We don't need those ducks at all. For some reason, we install ducks, but we don't care if they leak. It doesn't really make a lot of sense. When you're in hotter climates, the folks from Burgess, ducts tend to be outside a conditioned space, and duct leakage to outside testing and total leakage, they track somewhat closely to a degree. It's hard to get away with having really bad total duct leakage if you have to pass leakage to outside. And leakage to outside has been a part of our industry now, going back to version 2 of Energy Star, and you could get credit for it in the 2006 IECC performance path. And I feel like people have been there and done that in a lot of places until version 3 of Energy Star came around. Really, for the most part, people weren't doing total duct leakage testing. That wasn't a standard of our industry really whatsoever. Now it is more, but there are certain markets where until the tax credit became around. Rick, forgive me if I'm wrong, but were you doing very many Energy Star homes until the 45L came around?
Not with my current company. No, we a nonprofit or two, but not really. No.
Yeah, exactly. And so you still probably had a lot of leaky ducts from a total duct leakage standpoint, probably even as of just a few years ago. So these are the things that 310's just adding on something that we already knew was important. I think most of us as raters had a concept of HVAC performance, but we didn't really know how to go out and measure it. We didn't know how to test it. And so as a building scientist and someone who's an advocate for homes being better homes, I think this is a huge win that we've had this standard for the last 5 years. I think that Dylan brings up some good points about not being intimidated by it either, because especially if you're working in more of a production-oriented environment, builders are only going to put in so many types of equipment, and so you get used to that equipment, or at least I would presume that people would for the most part, and that allows you to troubleshoot it early on and then hopefully getting better over time, and it makes it fast. But to Dylan's point, it's a whole world of how to implement this standard. The options that you're going to take for certain steps of the process, they really depend on the home and the equipment being installed. The design should be pretty straightforward. Total duct leakage is pretty straightforward. But how you're going to measure blower fan airflow, it really depends on the equipment that's being installed. And it depends on, do we have single returns or multiple returns? What's the airflow, the total airflow of the system? Because that limits some of the equipment that you can use. Do we really have reliable static pressure numbers that we can derive, or do we want to do it more of a direct measurement with a flow plate? And then obviously blower fan watt draw, and I got to admit, a lot of people have been belly aching about watt draw in our industry, and I just say, cry me a river. I think that we all need to level up. We are energy raters. The idea that we can measure energy, measure electricity, to me is, duh, we should know something about electricity. And I understand it's a little bit intimidating, and I'm not trying to diminish it. Electricity can be dangerous if you don't know what you're doing, but there are ways to do this testing that are more non-invasive, less scary. And then finally, refrigerant charge. I still think that's probably, of all these steps, the one that we're trying to unpack a little bit more still. I'm going to go back here to Steve. Tell me if I'm wrong. These 5 steps, what has been the biggest sort of learning curve for implementation?
Learning curve, you'd probably talk about the watt draw. That's asking people to use multimeters that they're not familiar with. That's a new tool. As far as what has been, where's the gold mine of information is typically in the blower CFM. If you look at where we see high watt draws, where we see restriction with the blower CFM. So you can hit your CFM target, let's say, using a very high fan speed, but you're going to have a high watt draw behind that because you have such a high static pressure. Just in terms of the value of watt draw, I don't disagree with you, but I do think that you could probably do the blower CFM and then check the static pressure. And if those two check out, you probably don't need to put an amp clamp around a wire. Now, I'm not saying that we need to change the standard or anything like that, but in general, that is the risky part. That is the part that scares people, is reading the watt draw. And that's, you got to get over the fear factor on it, but we do it all the time. And once people get familiar with it, like you said, and once we try, we figure it out. Once we figure it out, we get good at it. Once we get good at it, we don't have problems. For the most part, I don't think that there's any single item on here that has been dominant. They're all a bit of a challenge as we go. Chris, what are your thoughts on that? Or
like from a business case, One of the harder things to deal with is the variation, even though we're working with production builders in a lot of these cases. Early on, it was you look at your choices for how you measure blower fan airflow. Which one are we going to pick? You can't really make your bed with just one of those each time. And so being able to scale that across Arizona, Colorado, Houston, Austin, San Antonio, all these places, that was a real challenge at first, was identifying what can we use all the time, even if it doesn't necessarily give the best 100% of the time, this is going to be the very best result. How do we scale this so that we can do a reliable test day in and day out without asking RFIs to put a camper bed on their truck to carry more equipment around than any other trade? So that was a challenging part early on. We've gotten that figured out. And then I think the watt draw has been one we got a lot of pushback early on. I'm not sure about if I want to do that. Do we have the safety protocols in place, and making sure that we did have a standard for how we did that so that people weren't blowing themselves across the garage or out of an attic or something like that. So all of those very early on were challenges that they seem to be in the rearview mirror now. So fingers crossed they stay there.
Okay. Rick, what about you? What do you think is a practical challenge in your market, or perhaps the greatest challenge of implementation of 310?
I thought the greatest challenge was, frankly, having our RFIs. We don't want them all using the ANSI 310 spreadsheet, running around with that, and having them figure out, having them know at the end of the visit, does the house pass or not? As we were rolling this out, we spent hours on that spreadsheet. You could get lost in there. Something's off somewhere, and you think it should pass. You're trying to figure out why it's not. So we really stripped that spreadsheet down and made like a mobile version of it that would look good on all the guys' phones and had the same formulas built in there, and took out some stuff that we would never use, some of the options in there, and really boiled it down to that so that they could say, yep, they passed or failed right then and there.
Okay, so not necessarily any one particular test, but just overall, like anything in our industry, if we add something new.
And the other thing, we had pushback on the clamp watt draw. I don't know if an inspector in Minnesota saw us doing a clamp on watt draw. If an electrical inspector happened to walk into a house, I don't know if that would be a problem. We're having to go into stuff that we probably shouldn't. I sparked 2 furnaces and hit the fuses blew in the house on them. Thankfully I thought I did the boards, but that was just super tight wiring from the electrician and trying to get in there, and there's nowhere to do it. So really getting the electricians to put stuff on, to put extra loop on there so we can have enough wire to work with. And then not walking into a house and having it be 68 degrees in the summer, because I'm automatically failing my return temp when the return temp is below 70 degrees on the refrigeration charge. I think getting the house set properly so we're not wasting our time or having to turn on the heat in the middle of the summer was really one of the hardest things to get to the construction managers and then to all the other trades in that development too.
And to that end, Rick, I really agree with you there. Also the problem where if you don't have the right outdoor temperature conditions, you also can't use the non-invasives. You end up having to use both non-invasive and weigh-in, because literally even in the South, half the year, it's going to be too cold outside to use a non-invasive approach. And then, like you say, on the indoor, it just depends on what you walk into to whether or not you can use it, even if the outdoor conditions are correct. If it's cranked all the way down, then you're waiting for the house to warm back up, opening a window or putting the heat back on. So yeah, we have a lot of non-invasives going down too, mostly here in Texas. And there are real challenges with are you there early in the morning when the temperatures are right? Or are you there later in the day where they're wrong, or vice versa, depending on the season? So the non-invasive is a real challenge because of those limitations.
And do you feel like you're getting the weigh-in method documentation efficiently then when you need it?
Wow, just today, the pictures are all correct, but the reporting can be off. It's one of those things where I can look at the scale and see that the guy put the right amount of refrigerant in based on the inputs, but then somewhere here and there, they'll say refrigerant added for additional components. I don't know, let's put an extra 6 ounces in there for nothing. And it throws out the whole thing. Now it fails. Nobody knows why it fails. And we're trying to figure out, why did someone feel the need to put that in there? Rick, when you said you removed some things, I was like, boy, there's one I really want to remove right now. No, I follow you. The reporting is a challenge because you think of a startup tech, they're out there in the field and they're going to do 5 or 6 startups today, and they're moving fast. And so getting them to take the time to do their information correctly so that everything works when we come back and do our part, there again is part of the challenge, because those guys only know a very minor piece of what part of what we're trying to do here. And if they're not clear on what they're reporting to us, then we're just going to have problem after problem. So there is a challenge there, make no mistake. But again, it's not any harder than any of the other challenges in any other phases.
And Rick touched on it too, with trying to take that spreadsheet calculator tool out of the hands of the consultants, the RFIs that are in the field doing the work. That's been one of our biggest sort of operational efforts behind the scenes, is how do we take that and put it in a usable format so that an RFI can punch in the numbers and they can know the grade without having to go through back office stuff. And then how do we give the startup techs a way to punch those numbers in also, so that they can know, hey, I'm adding 4 ounces too much, or when I turn this in, I can understand that I'm not going to pass. So right now we've built a form so they can fill it out and they can see, all right, I'm going to be at 8% deviation. I haven't done this, to at least give them some part in the process. Because before, they would just send us this document and then we would punch into the calculator and we would go back to them later and go, that's not right. That doesn't really work when you've got 1 day to get this done in a production environment. So we really felt like we needed to figure out, how do we give a tool to the contractor so that they at least know, when you send this to us and it says grade 3 on the calculator because you've punched in all the stuff about the house, that you didn't do it right. And I feel like if it were up to me, what I would like to see is that there would have been some sort of standardization of the tools from RESNET, that Rick and I don't have to go separately build tools to make our RFIs' lives easier, that there would just be something that we could go download and just say, all right, we're going to use this and punch in all the numbers. Something like the TEC Auto Test app, to where it's available for use and the use is already built into the process, but maybe that's just part of competitive advantage or something like that. But I really would just rather there be a tool that we could all use that takes that out of it. But I'm going to want it in this hand, and we'll see what happens.
I think one of the challenges that you have is that the people who write standards are smart and probably experienced in a lot of ways, but they're not. I think most people who help to develop this standard, what I'm showing right now on the screen, it doesn't actually show the specific 310 committee members as much as it shows the RESNET Standards Development Committee 300, which is more of a broader technical group. But regardless, the point I'm getting at is you probably had a lot of smart people on there, but not necessarily a lot of active production-oriented HERS raters who had some foreknowledge. And yeah, I would agree that next time we have something like this that's layered, multi-dimensional, we probably need to be setting up the rater community more for success out of the gate, because I got to imagine that there was a lot of people fumbling around in the field out of the gate, and some folks may just said, to heck with it. I'm not even going to deal with it. It's not worth it. It takes too much time. The spreadsheet is time consuming. I'm running into an impediment at whatever the step is. It's just not worth it. Sorry, builder. You'll just have to go back to track B with Energy Star and have your HVAC contractor credential, because I don't want to deal with it. And I'll say, when there was talk about the revisions of Energy Star, and particularly with the multifamily new construction program, that was particularly the feedback. Like, we as raters don't want to be responsible for this because it feels like it's a heavy lift to be implementing. And there's a question, are we really going to be compensated for it? That's a good question. Have we been compensated for it? Are y'all getting paid for this? Or is it just a competitive advantage, basically, that you know how to do it?
Like anything else, I don't know if it's handsomely, but we are compensated. We have a fee structure for that. So we treat it as a separate, we do it at the same trip as a final inspection, but we treat them as separate PO or invoice items. So it's not, we don't bundle that to the degree that we can't see the difference in there. But that was a big part of us getting the timing right and getting all of this pared down to understanding how long it takes generally on the job site, so that we could have pricing that made sense. Because when we started off, we were fumbling around. We didn't know it would take 2 hours to do it at the very beginning, and now we've gotten that down to a much more friendly amount of time. But we had to figure that out before we could go to a builder that wanted to do it 500 times. So we really had to figure out the timing to make the price work, at least for our business, having to do it in multiple markets with all different manner of national builders. So it wasn't, if it was just me, it would have been different, but having to take those things into consideration made it challenging.
Now, what about in Minneapolis, Rick? And you don't have to reveal all your cards. Like Energy Star had very low participation. Up in Minnesota, there were certain steps like total duct leakage that you probably were not having to perform, or even an HVAC design review, because really there wasn't very much participation. Whereas down south, Energy Star depends on the state. Let's take Texas, for example. Texas has always tended to have decent participation in Energy Star, whether it was for rebates or it's even code in some jurisdictions. I don't know, Rick, has it been worth y'all's while doing this?
Yes and no. I think we learned a ton. I think we learned a ton about our builders' HVAC systems and stuff, testing more. We learned a ton just on the market as well, on how, for example, in our market, you talk about duct leakage testing, nobody wanted to seal the boots. I had an HVAC or a purchasing manager for a builder tell me she got a bid for $900 to seal the boots in her house from the HVAC contractor. I was like, we will start sealing those boots. I will start a boot sealing company tomorrow. And I mean, and the ducts were tight. It was just like, but nobody wants to seal them off to the drywall or the subfloor or whatever. Yeah, I think it was worth it. I think there were some growing pains. I think at a certain point, the first summer we were really into 310 and we were failing house after house. We were really wondering, boy, are we going to see the light at the end of the tunnel here? Are the builders? I was wondering, is this going to be worthwhile for them? They're looking at it from a dollars and cents standpoint, but it ended up being worthwhile. I think builders got their tax credits. We learned a ton. We're now with the 2024 IECC potentially coming to Minnesota, mandatory duct leakage for the first time in Minnesota. We're able to now tell our builders what they're going to have to do to pass that. I think it was worth it from that standpoint. And we definitely charged for it. This was an extra line item right there. HERS rating, Energy Star line item, a 310 line item for an uncredentialed contractor.
Good, as it should be, because raters, when we have to spend work and effort and learn new things and get trained and buy tools, we should absolutely be compensated for it. Dylan, I'm interested to know from your perspective, you've had to go out there as our lead trainer of this standard. You've got the unenviable position of having to show up blind at houses all around the country. You don't know anything about the equipment being installed, who the builder is, and you have to be prepared to show whole groups of professional students how to implement this standard in real time on that piece of equipment. And I've been out there with you on some of these homes, and it's not always obvious how to go about it. So do you have a perspective about, let's say that you're in a market that's not dominated by production home building. Let's say you're in Massachusetts. For those who don't know too much about Massachusetts, it actually is the leading state for HERS ratings by percentage of homes that are constructed that end up getting HERS ratings. And that's because they have a stretch code that's been in place now for about 15 years. And it recently, just this past year, has become a lot more stringent. To pass the stretch code, you have to have HERS index scores in the 40s, in the mid 40s. And that's not easy for every home builder to do. And there's not a lot of production home building in Massachusetts. There's a lot of either one-off custom homes. There's a lot of sort of small, maybe regional production builders. So it's hard to get that kind of economy of scale. Yep, I know it's always going to be a Carrier furnace with a 3-ton AC, and it's this series. And so I know that it's easiest to test the watt draw inside the cabinet. I'm going to have the contractor cut a wire nut so I can get in there and do my blower fan watt draw, and I'm going to use the flow plates, and I'm going to do the non-invasive method. In a place like Massachusetts, you also have a lot of heat pumps in cold climate, variable capacity, variable refrigerant flow heat pumps, which cannot follow the non-invasive method. So I don't know, Dylan, what do you think? What's the hardest thing if you're like a rater in Massachusetts or Connecticut or Long Island or something like that, where you're not going to get a lot of economies of scale?
Probably the one hardest thing there is going to actually surprisingly probably be the watt draw, because those variable speed equipment, if it's cold enough outside or hot enough, but whatever it is, and you need it to run in heating or cooling mode, there's certain temperatures where you're not supposed to run that outdoor unit. And if you have just a normal traditional air conditioner or something, you can just go pull a fuse outside at the condenser, shuts it off. Air handler inside has no idea the outdoor unit's not running. It runs the same speed. It's fine. It's good to go. But a lot of those inverter systems get their power to the indoor unit from the outdoor unit. So if you stop the outdoor unit, now the indoor unit stops. So now you don't really have a way to get that watt draw. And there's a lot of homes where I genuinely don't have an answer for people on how to get the watt draw on that house outside of just waiting for the weather to be right for them to do it. And I think Rick mentioned earlier that he's had some pops, some sparks come out of an air handler, stuff like that. I've done that too. I show up blind on these, and it's a manufacturer I've never dealt with in a region I've only been to a handful of times. And a place like Massachusetts where you're doing one-off custom builds all over the place, even if you have the same builder, they might be using a different HVAC contractor or they use different equipment for some reason. You're going to spend exponentially more time doing these when it's new stuff to you. Like, it's not just, oh, it'll take twice as long. No, it'll take like 3, 4, 5 times as long, if possibly multiple visits for you to actually figure out how you're going to do it. And you might even realize, oh, well, this is how I would do it if I could access the wire, but the wire is so short and it's covered by insulation. I don't want to cut the insulation off. I'm not the electrician. I'm not the HVAC contractor. So now you got to tell your HVAC contractor or the electrician what to leave for you so that you can access things to test it. Yeah, it's just a lot of working with multiple trades, and hopefully your builder can step in and be like, hey, you guys talk to each other so that I don't have to be a middleman here and try to convey what my rater is trying to get to my HVAC contractor. Just get them in the same room, in the same email chain, whatever it is, get them talking directly to each other and try to make something standard out of it, which unfortunately is really hard when you're doing one-off custom homes like that.
Yeah, but think about it. In the cold climate, if you got an inverter heat pump, you might get 10 points on the HERS index. If you were, let's just say that you were in Massachusetts and under the old stretch code, you had to meet 55. And now under the new stretch code, you got to meet a 48. Well, shoot, what am I doing? Hey, builder, just put in a heat pump and let's do this HVAC grading. And you may not have to change a lot. You may still have a 55 level of a HERS index, but now we have tested and verified equipment. And look, I'll just say too, like BERcast, we like to talk about the business side and talk shop a little bit, but let's also talk about the practical implementation here. For those who have listened to the BERcast, you've heard us talk a lot about the realities of electrification. Is it a good idea? Is it a bad idea? And if it's a good idea, man, we got to get it right. Because if we don't, then it is a bad idea. If it's done wrong and we are putting in oversized and poorly installed heat pumps that are expensive, if you're going for a specialized cold climate heat pump, let's imagine that you're getting some kind of fancy Mitsubishi or something like that, and you're hooking it up to leaky ducts. And you didn't do HVAC design. You just had a contractor that they used a rule of thumb, or they got scared and they were like, the load said that it was only supposed to be 2.5 tons, but I'm going to put in a 5-ton unit just to make sure. That happens. And the consequence then is the homeowner is going to pay a lot more. The equipment's going to short cycle. And the cost of electricity is significant. In a lot of places around the country, the ratio of the cost per BTU, compared from if you have natural gas service to electricity, it's very significant. And if you're in a cold climate and this stuff gets screwed up, now you're dealing with people who have equipment that costs more to buy, sometimes significantly more. The contractor, not only is the equipment more, but then the contractor charges a premium because they're unfamiliar with it and they want to make sure they don't get burned. And then the operating cost is higher and it may short cycle. And so then things like dehumidification may be worse than had we gone with just a standard old gas furnace and a 13-SEER air conditioner, something that seems very antiquated compared to these more sophisticated systems. But that's the risk. And I hate to say it, but I've seen it in the real world here in Michigan. I've seen people who are ambitious. They want to go green. They want to be all electric. And look, I appreciate all that. I think that there's a value to that if done right. But here in Michigan, electricity costs 6 times as much per BTU than natural gas. 6. A cold climate heat pump maybe has a seasonal COP of 3. And that's if it's done. If you choose an awesome one and it's done, that means out of the gate, you're probably going to get twice as much the cost for a cold climate heat pump compared to a natural gas furnace in a cold climate. And that's if it's installed right. Now, if it's installed wrong and it's oversized, even more of the penalties. I think the value of HVAC grading here is bringing all these variables to the table, so we're really working through them. And I think builders are now getting a big opportunity because we're at this next step, or hopefully we're at this next step of the wave of evolution of building in this country. And we'll see. Obviously, if you listen to the last couple episodes of the BERcast, there's some storm clouds on the horizon potentially for our industry, but we want to be advocates for continuous improvement. We want to see those HERS index scores in the 40s. We want homeowners to have more efficient homes. But guess what? Builders are dealing with cost pressures. This is a way for them to potentially level up the home without necessarily breaking the bank. Steve, have you seen that as like a part of a sales pitch to builders? Has it worked?
Well, we have builders who've literally come to us and just said, I'm going to do ACCA whether I get the points or need the points or not. So builders do see the value, and large scale builders see the value in getting this under control. Just as a matter of perspective, all those items that you were mentioning that could go wrong that need to be verified on a heat pump in a cold climate, we have those problems in all areas. That needs to be verified everywhere. There's real value to this. On the duct leakage idea, even if you have code compliant and Energy Star compliant duct leakage rates, let's say 80 CFM on a 2,000 square foot house, if you double the system operating pressures, the air pressure within the duct system, you're no longer at 80. Now you're closer to 150. You're almost doubling the amount of duct leakage you have in the house because you're over pressurizing, even if you have good, what should have been a much lower leakage rate when you're operating at higher pressures, you're operating at higher leakage rates. Not only that, the cabinets leak. The cabinets are rated to 0.2 inches of water column, which is typically all you would see on the supply or the return side. But when they're operating at almost an inch of water column, almost double that on the supply and return side, the cabinets leak, and then you start getting condensation all over the equipment. My first foray into doing any of this was checking static pressures on units before we were even doing ACCA, because you could hear that they were overpressuring. I was dealing with 5-ton AC units set on 2-ton duct systems because of miscommunication. And this is on a production home builder, so this was on multiple homes where they had to go in and take out the 5-ton units and put in 2-ton units. So this has real value. We've caught broken dampers that aren't opening to serve other floors. We've caught undersized duct systems and returns. We've caught product design failures. There's one evaporator coil, I won't say the manufacturer, but one evaporator coil in this whole low GWP refrigerant changeover. This coil was a 5-ton that was producing 400 CFM lower than what it was rated at, and at a very high watt draw, 9 amps. And we could see right then when the AC contractor called and said, "What's going on?" I said, "Look, just looking at the numbers, it looks like you have a serious restriction somewhere." They said, "Yeah, we know we have a problem with the coil. We're going to get rid of that and switch coils." And think that was a large scale HVAC contractor. They would have messed up hundreds and hundreds of homes not knowing, had they not checked, had we not looked, had we not pulled this data. So I think it has real value. The builders know it has real value. And I think that value stands, like I said, it stands on its own with or without points applied to it. So I'm a big believer in the process. I think it can be improved, obviously, but I think it's done a lot of good for a lot of people, and I think it delivers, and I think builders see that.
Okay. Chris, you got a war story? What have you found anything different than Steve with the actual real world implementation? What's one of the things that you feel like you've really been able to take home for builders to make their systems better because of this standard?
I mean, Steve touched on a lot of the infield challenges, and that's really where the meat is, and he's done a lot of that work. I think one of the challenges I've had, and one of the things I've kind of taken home and been able to help, because Steve does a lot of the field stuff, I'm doing a lot of the back office and maybe some more of the sales stuff, is that there's getting builders to understand that all the stuff that you just talked about, all of the things that you got to get right, trying to get them to see that when we're talking about, here's what Burgess is going to charge you to do this work, and you'll get these points for it, that it doesn't just stop there. That it's not as simple as we go check off the 4 boxes in Ecotrope and then you get 7 points. It's that when we talk about all of these things, I don't try to scare them, but I try to show like this is performance as a specification. It's no different than if your blower door targets 7 ACH and you say I'm going to get it to 2 and I'm going to use that as my way of complying with a code or a program. Well, it doesn't just happen. It takes framers, insulators. It takes all these different stakeholders from design review to refrigerant charge to make it happen and to get them to really start to think about that and not just, well, we pay you X number of dollars and we pay the contractor to do it. And what we expect is that it just happens and we get grade 1 and we get a tax credit. So we feel like we've been able to do a good job of getting builders to see that it's going to be a process. I'm trying to think of a war story because Steve, we've had my favorite one was the damper one. We were on a house for like 4.5 or 5 hours for this builder, and we were testing we were using different methods to test the airflow and different methods to test the watt draw. We just couldn't get things to line up, and it was when we first kind of figured out that the flow grids weren't necessarily designed to fit in the plenum the exact right way, and so there was some diverging test numbers there. But it was at the end of all of it, there was a damper behind the return that was meant to divide the first and second floor, and that thing was pinned, and it was closed. And so, but had we not been doing ACCA 310 on the house, you really don't ever know. Like that doesn't ever, it shows up later on because downstairs is not getting any airflow. But that's where I felt like we really turned the corner inside of our own company of like, okay, this really has value, and it doesn't take having to go through all 5 of the pieces of the workflow to identify where there are challenges in these system installations. So to me, that was kind of a big turning point where I felt a lot more confidence in our ability to help builders understand where things go wrong with doing simple things like, 1 inch of water column static in the plenum, you got a problem. I don't even need to do anything else to let you know that you've got an issue with this system, and being able to deliver maybe simpler understanding for these builders that refrigerant charge doesn't matter if you've got a 1 inch of water column static pressure reading. You got something else you got to deal with. And so I felt like that was a war story. That was a brutal one, but it helped us turn the corner in even our own understanding of how valuable it is to the builder.
Yeah, and think about it now, like the way we're casually talking about these type of HVAC diagnostic terms and how to go and test and troubleshoot. 5 years ago, I think some of us in this industry were experienced enough to do that, but not very many. It was a shame. 5 years ago, Raiders didn't know that much about HVAC systems. They knew how to look it up in HRI. They knew where to find the sticker on the equipment to go look it up and take a picture of it. But we didn't really know much about how they worked and maybe what were some of the challenges with it. And now I think the people who have really decided to up their game by getting trained, by wrapping their arms around this standard, regardless of what happens with potential headwinds here with Energy Star, the 45L, I still think we're now armed to be a more credible asset for the home building community and to derive value going in the future. Rick, what's maybe a war story for you? If you ran into anything that really ended up saving the day because you guys were out there and found this?
Weekly, daily. Yeah, airflow speed set all over the place that would have never been caught. Yep. Looking at the HVAC contractor's paperwork in the house and saying, yep, this is supposed to be medium high, and yep, it's on low. We had problems. We caught probably at least 20 houses that were wired wrong with the new refrigerant in the systems. They've got the sensors on the inside, and there was not from what I understand, there was not a sensor at the compressor. But so in Minnesota, the electrician does all the wiring for the HVAC, and they don't communicate. So the electrician was wiring them, and didn't even know that there wasn't a sensor out there. So basically the furnace fan was going on high every 20 minutes because it was sensing a leak and trying to clear refrigerant. And we caught multiple, like 20 to 30 houses over a period of a couple of weeks with that. And finally the builder had to send the HVAC and electrician together through all their houses because they didn't want to get the summer come July in Minnesota and 90 degrees and nobody's got AC.
Yeah. So again, I think it's easy to talk shop and talk points and getting people tax credits, but there's something that matters even more, and that's ultimately ensuring homes that get rated. And I think sometimes this has happened in our industry. Oh, the home was rated and it gets this score, but the homeowner's not happy. They're not comfortable. The rater must have just did a drive-by or something like that. Sometimes there are certain things that were not part of our scope of work that we weren't educated or empowered to really go and be more of the technical expert to suss those things out. Now we are. I guess I'll talk about a little bit of a war story. There's a certain product out there, a proprietary duct system product that you might know if you've heard of it. And I think it's a cool product, but Dylan and I got brought in for a series of trainings out in the Mountain West through a utility in order to train some folks up on 310. And it blew my mind. I'm so used to seeing very high return side static pressure numbers.
Oh, yeah.
And we did. We did. Yeah. Because it was a single return and it was quizzically, it was like a 2-story house, and they ran the return all the way up to the very top of the second story. And so they had a single return all the way up to the very top of the second story. And so that's a great way to exacerbate the stack effect.
Yeah, it really will. Yeah, you're going to stratify that area fiercely.
But regardless of that being a dumb idea or not, when there's certain things that may have passed the paperwork and even passed the HVAC grading, but it was still something that maybe was not a good idea. But regardless, the supply side static pressure was actually higher than the return side. And, and it had this fancy proprietary duct system product, which is supposed to be very simple to install and great for design and commissioning and whatnot. And I think it made me educated that you got to dig into these. You got to get some experience with this stuff before you start selling people the moon and the stars, really, because here it was. His house had a cold climate heat pump in a place that gets cold, and their total system static pressure was like 0.9 or something like that. And that's not great. That's getting to the point where people are going to be pretty frustrated. And what I don't think a lot of people get, and maybe the evolution of this standard, is that maybe people start to understand, like, your SEER and HSPF values, they're a product of the equipment energy consumption in real time, basically. And then there's a seasonally average kind of a thing. But if you measure the compressor and you measure the air handler and you put those wattages together, that's what gives you your performance values. And so when we see 20 SEER, 13 HSPF or whatever, and we go, wow, that's awesome equipment. Yeah, but if it was rated to be performing at a 0.5 inches of water column, and now it's operating at a 0.9, you can still sometimes get your airflow in some of these variable capacity ECM systems, but the actual performance may be worse, which is why, Steve, I will defend watt draw to the bitter end, because it did show in the watt draw that is something you would actually pull out and say, okay, this was worse. You wouldn't have necessarily seen it just from the airflow.
Airflow with static pressure would have told you that, though, right? Airflow, they're hitting their target, but they're at 0.9 static. So we know and again, certain manufacturers will allow it to be that high. So I get what you're saying, that without a watt draw standard, they could be allowed. Carrier's a good example there. The 59 SCA furnace does not set a static pressure limit. So you could go up to 0.9 and it would be okay. So I agree, you're right. It still has its place.
But I do think that there's room for improvement, and we're going to talk about this. So the 310 standard is under redevelopment right now. Dylan, what do you know about where things stand with the redevelopment of 310?
Honestly, I wish I knew more so I could really properly answer that for you. I've been looking over the changes, and it really is kind of like maintenance stuff from what I can see. When they released it, of course, in 2020, SEER 2 and HSPF2 immediately came out right after that, or maybe at the same time. And there's all kinds of stipulations. Well, not all kinds. There's a stipulation in there where it determines your outdoor temperature range that's acceptable to do the non-invasive method, and if it's over 17 SEER, then your minimum temperature goes from 70 to 75 degrees outside. They did that, and then SEER 2 immediately came out, and so now what do you do with that standard? You got to convert everything back to SEER, or do you just call it the same thing? But from what I'm seeing, it's just a lot of maintenance stuff here and there that's fixing things. It's not really changing anything substantial.
We got to get you on that development committee quite possibly for the next version, which may be the 2030 version that we may have to wait for, but that's all good. I'm going to go ahead and say wish list item for that 2028 or 2030 version, because it may be a little bit too late. I'm pretty sure that they're probably trying to get the 2025 version out lickety split because ANSI standards have to be updated on a minimum of a 5-year schedule. So it may be too late for this time around, but the one thing that I'm going to advocate for, that I advocated for way back when, it's two things. And they involve watt draw, Steve. Number one,
Steve has now become the watt draw defender.
What have I done?
Yeah. So first and foremost, I'm going to go to both sides of the spectrum, safe to less safe ways of testing it. The standard should have never been written to say you can't test at the panel. If you are a professional and you know how to get into an electrical panel, it's actually potentially the safest place to test watt draw oftentimes, because you oftentimes have more ability to get in there and access the wires. And I understand that we have to be trained and we need people to have the right appropriate licensure, insurance, and their bosses want to sign off on it. But I've been testing wattage in electrical panels now going back for almost 15 years. I wanted to figure out air cycler systems, CFIS ventilation systems that use the air handler to distribute the ventilation. People who make up all types of nonsense numbers, 1 watt, 10 watts, 20 watts, they'd just be making up arbitrarily low numbers. And I wanted to know how much does it actually move. And so I invested in a watt clamp meter, an Amprobe NAV 51 wattage clamp meter. And I came to realize after some school of hard knocks is that testing in the panel was actually the fastest and safest way to get a reliable result. Rick had mentioned about tripping a fuse on the furnace before. I did that, getting into the service disconnect on the side, the switch on the side of the unit. And then you got this metal box and you got 2 metal probes and you got almost no wires. And so you're doing chopsticks trying to make it work. And I ended up blowing the fuse. And this was on a QA in an occupied home of all things. And so thankfully I was able to make it work. I didn't have to go and fix anything really, but I was able to use my MacGyver skills to get the thing back going. It wasn't catastrophic, but regardless, I'm an advocate for saying if we're professionals, let people do what they're comfortable with. And then the other thing to the other side of the spectrum is if a manufacturer has a fan curve table that publishes wattage at a certain static pressure and fan speed, let us use the damn number.
Amen.
If you're going to allow us to use the airflow from a fan curve table, why wouldn't you let us use the wattage?
Absolutely.
It doesn't make any sense. When I talked to one of the people who was the framers of 310, and they just said, we had to fight hard enough to get static pressure derived airflow numbers, and people just weren't confident in those wattage numbers. I'll just say, that's utter nonsense. I've tested them side by side with direct measurements compared to static pressure. And I'll just say, I don't think static pressure is always perfect. I think some equipment, it's actually harder to get a definitive, accurate number based off the equipment configuration. But again, that's a bigger issue with static pressure overall. If you can get a good reading and the manufacturer provides the watt draw equivalent, let us use it, because then we can get 2 for 1. And with no wires, no disconnect, nobody digging in the panel, nobody digging in the service disconnect. Easy peasy. Steve, how you feel about that?
It's still
buddy?
physics. I totally agree with you. And what we're seeing is with the equipment changeover, with the low GWP refrigerant new equipment coming in, literally all the new charts that I'm seeing are listing the watts out next to the flow rates. A few years ago, that wasn't there, or it was really hit or miss. Now it's hit everywhere. So the ability to use that, and I agree with you, the numbers are aligning for us. So I'm a big believer in that one as well. So yeah, I don't want to go down as the guy who doesn't want to do watt draw, but no, I do agree with you on that 100%. I would like to see that written in. You also, as long as we're doing the wish list, I'd like to see Measure Quick. I know know there's been a big push for refrigerant charge to be verified with MeasureQuick instead of the ANSI standard version. So I don't know if we're ready to move on to that, but that's on my wish list just because it's an app that already exists. Go ahead. Sorry, sir. Yes, sir.
No, I was going to say, how do we all feel about, they have this little kind of placeholder stuff in there about an independent verification report. You're halfway there, Chris, with what your wish list is. I'm curious on your thoughts. I feel like I know how you would answer this from knowing you as long as I have. Do you feel like an independent verification report that, other than duct leakage, let's say Raiders do duct leakage, but there's a report that exists that you get from an independent verification group of people? How do you feel about that? Are you okay with that? Are you willing to put your name as a Raider on there?
I'm hesitant. I think when we start doing that, then all of a sudden we're risking, I think, the same stuff that, why did Energy Star HVAC credentialing not really work? Why are we still solving problems that we're discovering through 310? Shouldn't this have all been solved through HVAC contractors going through Energy Star? So like, I'm hesitant to take it out of the hands of Raiders. I'd rather Raiders become more now. I'd rather that we become the ultimate residential commissioning agents and that we get paid for the work. And then in which case, what do we need the independent verification report for?
And what is it? Like I've never been able to get a straight answer about who can provide one. Who is, if it's not an ACCA credentialed contractor and it's nobody else, then who can? We've obviously never accepted one. No one's tried to give us one, but I just wonder if there's any sort of interpolation or extrapolation in the industry where people have munged something together to turn it into that, and they're not even really doing anything other than just taking a commissioning checklist from Energy Star.
Yeah, and that's where the issue becomes, has someone tried it? I guarantee you somebody's tried it.
And people may be doing it every day right now. You read the standard, it says you can accept that. You got to dig pretty deep to find out that you can't. So there could be Raiders out there accepting.
You got to go ask.
You got to go ask. If you just read the standard, you can use this all day long, yeah.
If you don't ask, then you can do whatever you want.
Yeah, now, the way this is written, it's meant to be something that an AHJ would be able to pick up and approve of. Okay, yeah. And I think that's the big opportunity, is that something like this, as we're trying to continue to move the needle forward with codes, maybe this is a solution. I don't know if they're looking at it for the 2027 version of maybe obviously the ERI will include it, but will the performance methodology, R405, will that also potentially consider it? Could it become just a part of the section R403 where it's just a mandatory requirement that you have to get grade 1? Wouldn't that be nice if we could get to that point? All right, so I'm hearing a wish list that more clarification at the very least of that independent verification report if we're going to accept it. Rick, what about you? You got a wish for future versions?
I think, backing up a second, something from RESNET, some program, some mobile app or something for the RFIs. We have one that works for our production builders now, but you go to upstate New York like Dylan was talking about, and you can throw that out the window and start from scratch again. I think something more simplified from RESNET that walks through it. Yeah.
Okay. Dylan, final thoughts? What about you? You got a wish list? Something to add for the future of the standard?
Yeah, I would like to see the static pressure method just go away completely. I know you're talking about either give it to us for both water draw and airflow, or take it away. I think it should just be taken away because it's in my opinion a little bit dubious to use. There's so much research and stuff you have to do, and it's so easy to miss something when you're talking about adding accessory equipment and stuff like that and different filters and all that. I would much rather just get the actual number from an actual testing piece of equipment that is true. And something I actually fought on for the 2025 version was that they're still going to allow you to skip the watt draw if you have less than 10 feet of supply ductwork. You could still have undersized. I know it's only 10 feet long. It could still be undersized. The return could be undersized. There's so many other things that could throw off your watt draw. I don't know why we're excluding it from that. It's not like it's harder to test because it has less ductwork or something. I think that should still be included, but I know that's a really small percentage of equipment, but why are we making this exception for that very small percentage of equipment when we should hold it all to the same standard, in my opinion. But those are kind of my two things.
Yeah, especially if you get into multifamily where you might have that kind of situation. I hate going into multifamily units and the equipment is just like loud. It gets turned on and just loud. I'm like, man, people already live in this tight space and they've got this super loud mechanical. I have a big problem with that. I'm sensitive to mechanical noise. I don't like it. So I feel for people who are moving into these affordable housing apartments and they got these undersized returns, super loud blower motors and things like that. I think that's too bad. So I agree with Dylan on that. Okay, you know what, guys, this was a big, long conversation. That was awesome. Bunch of field tested, battle tested HVAC graders, Raider nerds talking about HVAC grading and the quirks and the realities of doing it. And that's exactly what we're hoping to bring to the table here. I appreciate everybody coming on the BERcast to rap about this. Thank you very much, gentlemen.
Thank you, Chris. Thank you, Rick.
Thank
Guys
you,
have a great
Chris.
day.
Thank you.
All right. And that's a wrap. Nice long episode. Appreciate everybody being on here. We will see you next time on the BERcast. Talk to you then.